Afternoon, everyone. Today I will take you through the effectiveness of biplots and why you can potentially use them one day. So this might be a long presentation, or yeah, let's rather call it a lecture, but hopefully somebody will find value in these plots. We will start off with an introduction, and then I'll move to more technical parts where I try to reduce the mathematical formulas as much as possible. So the mathematics behind these plots can become very technical, especially since these plots rely on how matrices are approximated. But nevertheless, I will take you through one or two formulas from which these plots are built around. We will look at the SVD, singular value decomposition, which is the fundamental method of constructing these plots. And then we will move on to PCA, your principal component analysis, and looking at the more general biplot called the PCA biplot. And after that, we will take a look at some examples and other biplots and also how they can fit in the financial space. So imagine you have a n by p matrix you would like to extract information of. So generally, we are interested in plotting variables when analyzing data to see if there are correlations associated with any of the variables. Now, if you've worked in R or Python and you try to plot an n by p data matrix as a scatter plot, then you would get the plot on the left, which is technically does not tell us much. And if you show that plot to your manager and try to explain it, then yeah, I'm sure you won't get far, especially when you have more than 20 categorical variables. So now on the right is the same data plotted on a biplot. So I would take you through on how to construct this and how easy it is to read values of this plot. You'll realize that it is actually very easy to interpret the plot, even though it looks a bit populated. So the usefulness of these plots is that they use multiple variables to show dependencies of multiple dimensions on a 2D surface. So something the human eye can relate to. So the plot on the right also gives a bit of a spoiler as to where you have your principal components on the axis with a percentage variance explanation score on the horizontal and vertical axis. So this could be extremely useful, especially when we work with financial data. So let's move to the core component needed to derive these plots. So the main use of singular value decomposition is that it opens up matrix approximation. So here we have our X matrix, which is n by p, and this is equal to a matrix U sigma V transpose. So how this works is a r-dimensional approximation of X is given by the equation. Let me get my laser is given by that equation where sigma r replaces the p minus r smallest diagonal values of sigma by 0. So U is an n by n orthogonal matrix with columns known as the left singular values or vectors of X, and the matrix V is a p by p orthogonal matrix with columns known as the right singular vectors of X. And sigma is of this form. So the sigma matrix is a rectangular diagonal matrix with non-negative real numbers on its diagonal. So the diagonal matrix of the the diagonal entries of the sigma matrix are what is known as the singular values of X. And when you square those, you get the eigenvalues or the eigenvectors. And the number of non-zero singular values is equal to the rank or dimension of X. So the concept of approximation of a data matrix is the central theory in plotting biplots. So let's move on to PCA. So I'm not going to go into the mathematics of principal components as they can be derived directly from the SVD. However, we will look at how PCA is used to derive the biplot. So PCA is based on a dimension reduction technique applied to a set of correlated variables. It tries to retain as much information as possible when transforming the data set into principal components, which are uncorrelated and ordered. So the first couple of components are made to carry most of the variance that is found in the rest of the variables. So PCA biplots are primarily for describing variance in multidimensional data. So PCA as a statistical technique can be explained as a method to describe the covariances that occur within a data set. So it finds a new data set of dimensions where this new set is orthogonal and ordered by variance from highest to lowest of the data. So this is done by calculating the eigenvectors and the corresponding eigenvalues and then ranking these vectors from lowest to highest. So the first eigenvalues are chosen, and this forms the new n-dimensional data set. So let's take a look at some PCA biplot theory. So in general, you have the Eckert and Young theorem, which says that the r-dimensional Eckert-Young approximation is given by that equation there, with a matrix J, which is P by P, with this, which is just a matrix of ones in the first entry and zeros in the rest, which is minimized by this squared error loss. So the coordinates of the r-dimensional approximation of X is given by the first R columns of this matrix, and the direction of the axis is given by Vj. So the direction of the axis is very important, and also the coordinates given by the n rows of that matrix are plotted to obtain the r-dimensional plot and the p rows of Vj, which gives you the direction of the biplot axis. And the columns of V are often termed the principal components or the principal component loadings, and XV is interpreted as new latent variables, which are uncorrelated. So the variables which are represented by the axis of a biplot are derived using your PCA. So now that you understand a bit of the theory around these graphs, let's take a look at some examples of how they are plotted and why they could be useful. So in this first example, we have economic indicator data from 3 countries. So firstly, note that the biplot axis above represents the variables themselves. Okay, these axes are constructed by using the sample points and their respective variable values. So note that 3 variables are plotted on a 2-dimensional surface where normally a 3-dimensional surface would be needed. So when working with higher dimensional data, this will often result in a loss of information because of the use of approximation to construct these projections. But this, however, does not occur because the dimensions of these input data are still relatively low. So in figure 1, the observations are displayed in red. Okay, these are the respective countries that are being analyzed. And to read off the values from each economic indicator, one has to use the same methodology that is used to read 2D plots, such as scatter plots. So a line is drawn from each sample perpendicularly or orthogonal to each axis, and a value is read off that axis through the use of interpolation. Okay, so this is a very important characteristic of biplots when moving into the adding of new variables or axes to the plot, since it enables the user to obtain approximations of values for variables that are not in the sample originally. So now, secondly, the relations between different variables can be seen on the biplot. So when variables have positive correlations, they point in the same direction, such as V1 and V2, with the values of the axis increasing in the same direction. However, when the variables have negative covariances, the axes point in different directions. And when the variables are uncorrelated, they will be plotted perpendicularly on each other, with the values of the axis increasing in any direction. So this is also another powerful tool of biplots, since one can easily and quickly identify how dependent different variables are on each other by simply looking at the angles between them, or rather between the axes and the direction of which the axis values increase. So the next example, we consider VAR data for 20 days. So plotting an instrument's VAR over time assists management in identifying trends. So the portfolio considered here consists of 7 financial instruments which are not performing independently of one another. So the calling for a multivariate approach for analyzing these VAR figures calculated for each of these 7 instruments on a daily basis is needed. So the biplot axes shown here are prediction biplot axes, and the approximate values for the individual financial instruments can be read off from the axis. So predictions for selected sample points can also be obtained. So here we note that on day 2 and or rather on day 2 of the absolute VAR of EDM, the absolute VAR of EDM was particularly large. This is in sharp contrast with day 16 exhibiting a very large absolute VAR of CM. So this is the type of useful information financial planners and managers need to notice of. They can now research the circumstances surrounding EDM at the beginning of the period and those of CM towards the end of the period to suggest in the future what circumstances could lead to high risks on EDM and CM. One could also argue that just by simply plotting a line plot over time of EDM or CM, this feature would also be highlighted. But the advantage of the biplot is that it gives you a global overview of the interlinked financial instruments. So as a next example, we have the PCA Biplot, which demonstrates how certain variables such as financial risk indicators change over time, as well as displaying the relationships between the changing variables. So on the buy map here, securities that are similar are positioned close to each other. For example, there is a neighborhood of gold shares and close to that, there's a neighborhood of platinum shares and a neighborhood of resource companies. So there is also a neighborhood of bank stocks, which is far from the resources. So the distance from the origin is the volatility of the security, and the angle made by 2 points at the origin is the correlation between them. So if 2 points are in the same pie slice as each other, they are highly correlated. For example, in the map above, the bond indexes of increasing duration, LB 1 to 3, etc., are highly correlated with each other. And if 2 points are at right angles to each other, such as Pick and Pay and Anglo Gold, then this indicates that the shares returns are uncorrelated with each other. And lastly, if 2 points are across the origin from each other, this indicates that they are negatively correlated with each other. So here we can see that cash almost sits exactly on the origin because its returns are so stable. And the various bond indexes sit quite close to the origin and off slightly to the right and slightly anti-clockwise from the bonds, but still close in angular sense, indicating strong positive correlation with the bonds, are the interest rate sensitive stocks, which are these. So firstly, in an angular sense, the retailers Pick and Pay, Mr. Price, and Foschini, and then the banks like ABSA and First Round, and then industrial stocks such as Imperial and Advitech. So on the left side of the map are the gold shares, Harmony Gold and Anglo Gold, which are highly correlated with, but more volatile than the gold price, gold NY. So they are more or less at right angles to the bonds, implying that they are uncorrelated with interest rates. So as with securities, the distance of the portfolio from the origin gives the portfolio's volatility, and the added diversification reduces risk can be seen from this. So port 1 in the diagram has far less risk than either of its two constituents because security A and B are not well correlated. So also note how port 1 is much closer to the origin than either the securities A or B. Okay. So port 2 has only slightly less risk than either of its two holdings because security C and D are highly correlated. So in the BIMAP here, AGL has, in the BIMAP, AGL has the lowest volatility and also the largest tracking error from peers. And AGL has the biggest tilt away from resources on the left of the map. AGL will therefore underperform if the market as a whole uh, underperforms, and especially if resources does well. So AGL will outperform if the market as a whole does badly, especially if resources does badly. And OMEG has the highest absolute risk. So it would also be interesting to see how Gred's Bitcoin portfolio would be plotted in this space. So now we move on to other types of biplot. So your CVA biplot works with segmentation and is suitable when different classes are being compared. So this can be useful when working in the world of credit risk, since a company representing since a biplot representing financial indicators of each company within a sector can be displayed and connected. And CVA biplots also provide means of classification, whereby making it possible to build prediction models to identify if a company will, let's say, go bankrupt or not. And not only can these plots be used as a visualization technique, but each plot is constructed in such a manner to provide statistical and financial analysis. So this plot focuses on grouping observations into classes and then studying the between class and within class variation or variance. So this entails transforming the observed variables into canonical variables or the means to canonical means. However, the mathematics is a bit complicated, and I'll leave it to those that are interested, because it gets very complicated, especially when you have to start proving how these CVA biplots are constructed. So then lastly, we have our density biplots, which speaks for themselves. So here you can see the concentration of how companies are situated based on their financial ratio performance, with the financial ratios as the variables on the axes. And these plots therefore provide a nice overview of how powerful these visualizations can become. So yeah, some interesting research that I came on in particularly was in interest rate swaps. In this, I think it's a master's dissertation. So in interest rate swap, one needs to calculate the effective exposure of the swap in order to make counterparty credit adjustments. So one of the most popular methods that we know of, but rather computationally intensive, is to calculate these exposures through Monte Carlo simulations. So in this study or master's dissertation, alternative method of calculating the effective exposure using biplot interpolation is proposed. So if anybody is interested, I think that there could be some really interesting findings. And then lastly, two huge books on biplots. So I had the privilege at Stellis to be lectured by both authors, Michael Greenacre and Prof. LaRue, but both are at the forefront of biplot research in the world. And if anybody is interested in these books, I can share them. Yeah, but yeah, that's all for me. Thanks, everyone.